the asthenosphere, then there is a mantle, and then there is an outer core and inner core. So we studied this structure. We also studied its composition also, chemical composition. But how does it like appeared to us? How do we know that the interior of Earth is like this? So for that we have some evidences. Okay, and to get these evidences, we have like various things. Like first, the studies of meteors. The studies of meteors. So those meteors or meteorites, not ride, which landed on the Earth's surface. We studied them. Okay, and after studying these meteorites, we came to know that this kind of material may be in the Earth's crust also, or in the Earth's mantle also. Okay, so that is one evidence, the study of meteors. Okay, then there are the evidences where we deeply bored inside the Earth's surface. Okay, we dig deep and we find the rock structure, the changing rock structure. We also found that as you go deeper inside the Earth, there are two phenomena. First, the temperature start rising. Okay, the first thing is the temperature start rising as you go below the Earth's surface, Earth's crust. Okay, and second thing is the pressure also increases. So this temperature and pressure increases as you go deeper inside. But this has also its limitation because you cannot dig deeper. Like you can dig like 10 kilometer, 15 kilometer max, but beyond that what will happen, the temperature will be such that your machinery may not reach below that. But we have studied yesterday that your core, outer core starts at 2900 kilometer, right, radius. So this much depth we never went to, right? So you don't know that what is inside. So there are third type of studies. Okay, so these type of studies are conclusive evidence. They give conclusive evidence of what is inside of the Earth's crust. Okay, so these studies are called as a seismic studies. These studies are called as a seismic studies. So what are these seismic studies? Let us see. So understand first that whenever Earth shakes, or we call it as an earthquake, whenever there is an earthquake, what happens? Earth releases energy. Earth releases the energy. Now, this release of energy is of two in the kind of waves. Okay, this release of energy is in the form of waves. Now, these waves are of two types. Okay, these waves are of two types. One is a surface wave, another is a body wave. Okay, so what we are seeing now, whenever there is an earthquake, whenever there is a shaking of the earth, then the energy is released. Project, I think your mic is on.
Sorry,
So
sir.
whenever, no issue, no issue. So whenever the earth shakes, earth releases its energy. Now this release of energy is in the form of waves. Okay, these waves can be of surface type or body waves. Okay, now surface waves are called as S waves. Okay, now these are different waves. Surface waves are different waves. Now we are not going to see at this moment surface waves. We are more interested in the body waves. So what is body wave? Body wave is nothing but what is inside of the earth. So that is earth's body. Okay, so whenever there is an earthquake inside of the earth, okay, inside of the earth's crust, some earth waves, the wave starts moving from this point. Okay, suppose at this point there is a fracture. Okay, like this, for example, there is a rock structure and suddenly there is a fracture. So because of that, earth shakes, earthquake happens, and because of these earthquakes, from this point towards every other direction, wave starts moving. So inside of the earth's crust, those waves we call them as a body wave. Okay, Now the body waves are of two types again. One is called P waves, second it's called S waves. Now in body waves, P waves and S waves means what? P is nothing but primary wave. Primary wave. S is nothing but secondary wave. P is called primary wave. S is called secondary wave. Okay. Now these primary waves has its a different property. So what is the property of primary wave? And these properties are helpful for us to understand what is happening inside the earth. Okay. And based on these evidences, we can conclusively say that, okay, the earth structure is like this. There is an asthenosphere. There is a liquid layer there. Okay. There is a inside core which is solid. So these all conclusive evidences are coming from the study of these waves. Okay. Now let us see what is happening. So first understand the properties of these waves. Okay. So the first wave is a primary wave, P wave that we call. Now P wave are also called as a longitudinal wave. Longitudinal waves. P waves are also called longitudinal waves. Okay. Now how they vibrate? They vibrate parallelly. They vibrate parallelly like this. They are like sound waves. You know, sound waves vibrate parallelly. These are longitudinal waves. Okay. Now, the important properties of these primary waves is they can travel from both solid as well as liquid medium. Okay. They can travel from both solid as well as liquid medium, and that is their property. Okay. So this is very important property that they are traveling in liquid medium also. Now, there are other waves, that is secondary wave. Now, secondary waves are also called as a transverse waves. Okay. And transverse waves have perpendicular vibrations. Transverse waves have perpendicular vibrations like this. So they vibrate perpendicularly in 90 degrees. So this is the particle, they will pull it here, they will pull it back. Okay, like this. They vibrate in a transverse manner. Okay. Their vibrations are transverse. So these are secondary waves. Now, the important property of these secondary waves is that they can only travel in the solid medium. They cannot travel in liquid medium. They cannot travel in the liquid medium. So that is their property. Okay. So this is basic understanding. The primary wave, which can travel in solid as well as liquid. The secondary waves, these are transverse waves, perpendicular vibrations, but they can only travel in the solid medium and not in the liquid medium. If we can understand these two facts, then the next thing is very easier. So let us see what happens. Now, we know better that, and one more thing about these two waves, whenever, and both of the waves are traveling in the solid medium, that is true, but both of the waves will travel faster if the solid medium is much denser. So if the solid medium is denser, the waves, both of them, will travel fast because there are particles. Okay, there are close compact particles, so they will travel very fast through this medium. Okay. And if the material is lighter, that is not much denser, then the velocity, their velocity will be less. Their velocity will be less because in the lighter material they are traveling in the rarefied material. It's not denser, so their speed reduces. They travel slowly. Okay. Now, till here everyone is clear. Now there are some observations. Okay. There are some observations regarding to these two waves. So what are these observations? So first observation is that, now see how these observations are calculated. Let us see. Let me show this. Now suppose there is a earthquake here. Okay, inside of the Earth's crust, let's say like around 80 to 100 kilometers deep. Okay, this point is called as a focus, the focus of the earthquake. So at this point, something has happened. The Earth's crust may, or Earth's interior, like crust ends there, the crust has broken somewhere, and the earthquake happened. So simultaneously, what happens? The wave starts coming towards the surface. These are body waves. These are P waves and S waves. They are started coming towards the surface, and we have seismographs, the standard seismographs located in the different parts of the world. Okay, so these seismographs will capture their, they will capture their intensity, they will capture their properties. Okay, so these seismographs will study them, and then we can conclude. So what we can conclude what is happening inside. Okay, so these observations, now let us see what are the observations whenever such earthquake happens. So what are the observations? The first observation is that P and S waves, P and S waves exists as the set up to a depth of 2900 किलोमीटर. दोन्ही पी आणि एस वेव्स काय आहेत, ह्या किती किलोमीटर पर्यंत आपल्याला दिसत आहेत क्लिअरली, अप टू 2900 किलोमीटर. पण बियॉन्ड दिस, आफ्टर 2900 किलोमीटर जर गेलो आपण, पण बियॉन्ड दिस व्हॉट हॅपन्स? यस disappear. Yes, wave disappear. आता why it happens? Let us see. This is Earth. Okay, and you know better that there is a outer core, there is an inner core. But outer core is made up of liquid material, right? So whenever there is a earthquake, what happens? These waves starts here. They are started coming towards the surface. Now they include both P waves and S waves. Now I am drawing only S waves, suppose. Yes, waves. These are secondary waves. Now they are traveling through the mantle. This is mantle. And you know better that mantle is also solid. But this is the outer core, which is outer core. This is liquid. So when they come towards the liquid core, when they come here, they will not be allowed inside the liquid core because this liquid stops them. We understood that S waves cannot travel in the liquid medium. So here they will stop. They will be stopped. Now the angle, this angle where they came, like here is a 0, suppose. So what is the angle that they are coming out here is 103 to 108 degree. So till here they are present, but beyond that they cannot come. On the other side also they are coming, like from here they are coming to this surface. Here we can also record them. Here also we can record them. Here also we can record them. But beyond that we cannot record them. So here also it's a 103 degree to 108 degree. We can record them. To whom? To S waves. Okay. Why beyond? Why they can't come in this area, this region, this green region that I am drawing now? We cannot get their evidence, or we cannot find them in this region. This region is called as a S. This region is called S shadow zone. This region is called S shadow zone. So why they are not coming in S shadow zone? Because when they come in contact or nearby this area is a liquid core, outer liquid core. So when they come nearby it, they cannot come inside, and that's why they get disappeared, because they cannot travel in the liquid medium. Okay, till here anyone has any doubt? So this angle 103 to 108, how it is calculated? From 0 till here, maybe 90, then 103, 108. You understand? So because earth is पूरा round कितना है? 360 degree. Okay, anyone has any doubt till here? regarding to S waves? You will study this in your NCRTs also. Okay. Yes, anyone? No doubt? You should talk, right? Otherwise, how could I understand that you people are having any doubt or listening properly or not? Okay. So you understood, yes, shadow zone, right? Now what happens? Let us see. The observations are going on. So the second observation is that both first observation we have gone to. The second observation is up to 2900 kilometer. To 2900 kilometers. So what is this 2900 kilometer? So this is till there here till the outer core it is 2900 kilometer. Okay, when you come towards the outer core it's 2900 kilometer. This is the radius till outer core. Okay, so up to 2900 kilometer there is a solid material because you have till here you have mantle. So what happens whenever you start traveling from the crust towards the mantle, the speed of the waves increases. Whenever you start traveling from the crust towards the outer core, the speed increases. So why this speed increases? Then what you can conclude? You can conclude one thing from this, that as you go down, as you go towards the interior of the earth from the surface, what happens? The density of the rock increases. The rock density, because we have studied earlier that if the rock is denser, these waves travel faster. If the rock is not denser, they travel very slowly. Okay, so we are finding that up to 2900 kilometer, as you go deep, speed slowly increases from top to like towards the core. Clear? This was the second evidence which shows that yes, towards the core of the earth there is a denser material. So earlier, yesterday also we understood that the outer layer of the earth, this part, okay, this is the earth's crust, and earth's crust is very lighter. Yesterday we have studied this. This earth's crust is a lighter. They are made up of silicates. Okay, it is called sial, silica and aluminium. So the speed is lighter, speed is lesser. But as you go deeper, as you start coming inside of the earth's crust, then mantle, then speed increases because the density of material increases. The density of the material increases towards the core. This is our second observation. Now, what is our third observation? The third observation is that the S waves की क्या बारे में क्या what the observation is, S waves refract and emerge at an angle of 103 degree to 108 degree, but beyond that they disappear. है ना? आपण वरती बघितलं इथं की beyond that they disappear. So this region is called S shadow zone, where they can't be found. This is S shadow zone. Okay. Now the next observation, the fourth observation is that there is one layer. Okay, there is one layer which we called asthenosphere. Now, when these waves are passing, tell me anyone that whenever these waves start passing through asthenosphere is just after your crust. So this is the crust. So after the crust, we have a layer called asthenosphere, right? So anyone tell me, whenever the waves start passing through the asthenosphere, whether their speed will increase or decrease? Increase or decrease, tell me.
Decrease.
Yes, their speed will decrease. Why? Because it is made up of semi-solid or semi-molten. Semi-solid. It is like chewing gum. We yesterday talked, right? So their speed slowly decreases. But again, when they come out of this asthenosphere, so let us see, they emerged here. They start going now through the asthenosphere. Their speed decreases. But now, after asthenosphere, when they come out, their speed again increases. Okay? Okay? Why? Because asthenosphere is semi-solid or semi-molten. Okay? Now, till 100 kilometer पर्यंत, these are observations. Till 100 kilometer, their speed is around 7.8 kilometer per second. 7.8 kilometer per second. But beyond 100 kilometer, their speed drops. How much? 7 to 7.3 kilometer. हे ड्रॉप का झालाय? बिकॉज देयर इज अ ऍस्थेनोस्फिअर. यू अंडरस्टँड? कारण 100 किलोमीटरच्या लेअर मध्ये ऍस्थेनोस्फिअर असेल असं काहीतरी आहे की तिथून जाताना या वेव्हचा स्पीड ड्रॉप होते. द स्पीड इज ड्रॉप्ड while passing through this area after 100 kilometer. So you concluded that, oh, in this area there must be some material which is not that dense, which may be semi-solid kind of. Okay, so this is how we understand that there is a one layer called asthenosphere. We never gone inside 100 kilometer parent, nobody has gone, right? But how we know it? It is known by this fact: the speed decreased suddenly. Okay, but after some distance again speed increases. So when it increases, speed again increases after 300 to 400 kilometers. So beyond this 300 to 400 kilometer, speed again increases. So asthenosphere is also called as low velocity zone. Asthenosphere is also called as low velocity zone. Okay, now beyond 900 kilometer, after 900 kilometers, speed drastically increases. Why it is increasing? Because the density of rock is now much more. The rock's density increases. As rock's density increases, the waves start moving in faster manner. Okay, so the density is very important factor for their movement, and that's how we are understanding these inside structures. Okay, now beyond 2900 kilometer, what is happening? Beyond 2900 kilometers. So what is 2900 kilometer? From here, core starts. Okay, beyond 2900 kilometer, core starts. So outer core starts after 2900 kilometer here. Okay, beyond this, what happens? You know better that totally yes, waves are disappeared now. So only remaining waves are which? Only yes, P waves, primary waves, which will pass. Only P waves, that is primary waves, will pass through this. So how it happened? Let us see. Okay. This is Earth. This is outer core. This is inner core. Okay. Now, suppose the wave started moving from here. This is focus. Remember, this where the earthquake happens, this point is always called as a focus. And where the wave emerges out, just above the focus, we call epicenter. What we call epicenter. Okay. Now, let us see. From the focus, the earthquake wave started moving towards the surface. Okay, they're coming towards the surface, and now these waves are all P waves. These all waves are P waves. Now they are coming here. They are coming in contact with the liquid core now. They are coming in contact with the liquid core. So tell me what will happen. Will they pass through the liquid core or not? Yes? Will they pass through liquid core or not? Tell anyone. Will they pass through liquid core or not?
They will.
They will pass. Why they will pass? Because they can pass through both solid as well as liquid. That is their property, right? So they will pass. But one thing will happen, that whenever they start flowing from solid to liquid, their refraction will change. Like they will refract. We have studied this, right? Whenever a light ray pass through a prism, like suppose there is a light ray, when it pass through prism, it will not go in straight line, it will deflect, it will bend. Okay, similarly, whenever these p waves are passing through this liquid, they bend, they bend like this. Okay, they bend like this. So whenever they are passing, they will bend like this. Okay, and then again, now from liquid to nearby solid they came, towards the inner core, towards inner core they came, from outer core. Outer core was liquid, they bended somewhat. Now they come to the surface, or they come in contact with the inner core. Now there is again phase change from liquid to solid, so they again bend. Okay, so this is how they are coming. Okay, and now again from solid to liquid, again refraction. Okay, and somewhere they come out, but they will come out because they can travel in both solid as well as liquid medium. So this is their property. And here the person standing here, this person can record these S waves in this region. Okay, the person recording which type of waves? Primary waves in this region only. So here, this is 143 to 145 degrees. Same here, 143 to 145 degree. Till here only we can guess, or we can find P waves. And here also we have found P waves. P waves. Here also we found P waves till here. But now in this region, the region which I am making greener, okay, this region, in this region, you do not find P waves. So this region is called as a P shadow. This region is called P shadow. Shadow means there you are not able to see the P waves. The P waves are not seen or not detected. Now, why they are not detected? They are not detected not just because they cannot travel to the liquid core. No, that is wrong explanation. So, why they are not able to detect it, not getting detected? Because they were refracted. They were refracted when they were propagating due to refraction. So this P shadow is because of refraction. Refraction of the waves. These waves refracted. Okay. Understand? So this is how we understood. Now the refraction shows that, why they would be refracted, because there may be some liquid region, again refracted because there may be some solid region. Okay, and that's how we get the P waves here at the other side. So if we say the focus was here at O point, suppose, but we are getting P waves at the other corner of the earth, exactly opposite of the earth, suppose this location. Okay, so why it is happening? Because they can travel in both liquid and solid medium. You understand? So this is the conclusive evidence. So seismic waves study is a conclusive evidence. Conclusive evidence. कशाचं conclusive evidence आहे की अर्थच्या इंटिरियर मध्ये काय असेल, व्हॉट वुड बी देअर इन द अर्थ्स इंटिरियर. Okay, till here anyone has any doubt, or you got the
सर
point
मला
what I mean?
समजलं नाही, म्हणजे मला हे नाही
Okay.
समजलं की हे पी शॅडो मध्ये रिफ्रॅक्ट झालं म्हणजे नक्की काय झालं.
हा, म्हणजे काय झालं, ज्यावेळी जस्ट सी दिस इज द आउटर कोर सपोज, and this is the inner core. ठीक है. When wave come here, when the P wave come here, it will not go directly like this. Okay, it will not go straight like this. Okay, it will bend. Why it will bend? Because of phase change. We have seen this experiment in our school days, that whenever the light passes through prism, so this is the prism, or this is a block of glass. This is the glass. when the light passes through the glass, it will not go in straight line, it will bend somewhere. Okay, similarly, this P wave, when it is coming, it will not come directly like this or go like this. It will bend somewhere. It will bend somewhere and it will bend and then come out. So what happens that you will not get this P wave somewhere in this region. So that's why this region we are calling shadow, where it is not available. Why it is not available? Because it has bended, it has turned somewhere. Okay, and it is not appearing in this region, so it is turning and appearing in this region. It is going, changing its direction, coming here. Okay, but beyond that it is not coming. Why it is not coming? Because its direction has changed. You understand? Like this only, just see this glass. Okay, now when this ray, this green ray is coming, what you will expect? You expect that if it has to reach to this O point. Why you expect that? Because this should, you believe that this should pass straight line, in straight line. But it is not passing in the straight line because there is a medium called glass. Now this glass medium will turn this ray somewhere in this direction because the medium is changed, because here it was air and here it was glass. Now similar situation is happening. This bending, this turning will, what will happen because of this turning? In this region you will not get no ray, but the ray is coming here at somewhere like A point. Okay. Similarly, it is happening here that the material is changing suddenly from solid to liquid, from liquid to again solid, again from solid to liquid. Okay, so this material change leads to what? Multiple refractions, and because of that, you will not get the S wave in this P wave in this region. Am I clear, or should we explain again?
No, sir, I think it's clear.
It's clear. It is just, remember, it is because of this material change. Now from air to glass it is going, that's why it is bending. Similarly, whenever the P waves are going from one medium to another, they are shifting, they are not going in the their destined path. Earlier जो path हमने देखा,
Right.
not going in the straight line. Yes, they will bend, they will change their path.
So it's
And because
like
of this change,
it's the same phenomena, right? Like where we see like पाण्यामध्ये आपण जेव्हा दगड बघतो सो ते डायरेक्ट नाही दिसत आणि ते
yes,
दुसरीकडे
yes,
असतं.
it will be seen somewhere up, right?
राईट. ओके, गॉट
पाण्याचा
इट.
तळ थोडा आपल्याला वर उचललेला दिसतोय. Why it is happening? It is because of this light's refraction,
ओके,
right?
या गॉट इट.
Same phenomena. Okay, इथपर्यंत बाकीच्यांना कुणाला आणखीन काय शंका आहे? एनीवन? Ajinkya, do not speak usually. Ajinkya, I know you are sitting in library. Better you can sit in your room so that we could interact better. Yes? Am I clear? Okay, better, because we want this kind of interaction. Otherwise, I'm just, it will be a monotonous talk from my side. Okay. Now, this is just simplistic model. What just we have seen right now, this P waves and S waves and the structure of the earth, okay, that there are layers. So this is just simplistic explanation. Is it this simple? The question is this arrangement, that there is an outer crust, then there is a asthenosphere, then there is a layer of mantle, then there is outer core, inner core. Is this such simple? No. The answer is no. Okay, but we don't need to go deeper into it. Okay, now there are new concepts which are coming, that it is not like only outer core is liquid. They say these concepts are called as a surge tectonics. This is not there for our syllabus. But what is surge tectonics? Surge tectonics say that the earth is still not fully cooled. Okay, it is still hot, it is still changing its nature, and that's why what happens somewhere inside, because of the residual heat, there are some spots where there is a liquid, there are some spots there where there is a semi solid material. Okay, So it is not that these layers are perfect. Okay, perfect means okay, from here only this liquid material will start, from here only solid material will start. No, not like that. Okay, so we cannot predict what is inside because we have not gone deeper inside. You understand? So still it is evolutionary science that we call. Okay, still evolving knowledge, right? Okay. So till here, the question is always asked like this only. Like this is a preliminary question actually. Prelims ला हा important आहे की P shadow काय असतो, S shadow काय असतो, कधी येतो, what is P waves, what is S waves. Okay. आता जो important भाग आहे that we are going to take is a great theory. It's called continental drift theory. Continental drift theory, and the question is always asked, actually asked earlier also, and this is important theory. Okay, what is continental drift theory? Let us understand. So what happened? Geographers were fighting amongst each other ki how the earth's surface is such, how the earth's surface is such obad gobad, right? So there are some mountains, then there are valleys, there are peaks, okay, there are plateaus, there are ocean basins. Why is it so? Okay, the earth's surface is not perfectly plain like this. It is not a stretched membrane. Why there are these bumps? Why there are these plateaus, these mountain systems, these valleys and rivers? Why is it so? There was one person, his name was Harold Jeffrey. Harold Jeffrey. So Harold Jeffrey was a geographer. Harold Jeffrey said that I will tell you how these wrinkles, he say wrinkles, turkutya, how these wrinkles are formed on the earth's surface. He says that it is just like a boiling milk. Earth was like a boiling milk. Okay. Current Earth's surface, we see in the first, second lecture, we saw that the magma which was there around the Earth's surface, which was hot liquid. Okay. This was a magmatic material earlier. And slowly, it got cooled. Similarly, हे जर आपण बघितलं की it is a milk, suppose this is a milk pot. Okay, and milk is boiling now, just like earth. And this is burner. When milk is burning, what will happen? After some time, you will get a creamy layer on the surface of milk. You will get a creamy layer. Yes. Now this cream is lighter. That's why it is floating over the milk, right? So this is lighter milk. Now, if you observe carefully, this cream has this kind of folds, or this milk's surface is not stretched like straight. It has some bumps. Yes. Similarly, Harold Jeffrey says when the earth was started cooling slowly, then the earth also got the wrinkles like this. Okay, so it is not straight, like it is not plain surface, but these kind of wrinkles. So his theory, he called it is a thermal contraction theory. This theory he called thermal contraction theory. Thermal contraction theory. Okay. Now, because of he said this, that the earth was cooling slowly, and because of these wrinkles, and that's why these wrinkles can be mountain or valley. These wrinkles can be mountain and valleys. But is it true? It is not true, because all the mountains of the world are not similar. We have studied in I think last lecture that there are different types of mountains. Some mountains are fold mountains, some mountains are fault because of faulting, some mountains, and various reasons are there, right? Volcanic mountains are there. So the rock is different. Fold materials are rock, fold mountains are rock, sedimentary, right? Fault some rock different type, volcanic rock for volcanic mountain. So different mountains or different features have different varieties like chemical composition, physical composition. But Harold Jeffrey is not able to tell about this. He says everything is uniform because this is thermal contraction theory. So his theory was rejected. Okay. Now there was another person who said that these features are because of the different phenomena. So this person was actually Taylor. Taylor. Taylor gave its drift hypothesis. Drift hypothesis. Drift hypothesis in 1908. Okay. Taylor was a person who gave another theory. It's called drift hypothesis. Now he says that there were two big continents. There were two big continents. One is called Laurentia. One is called Laurentia, and another is called Gondwana. Okay, one is called Laurentia, another is called Gondwana. And in between these two big continents, there was an ocean. There was an ocean. He said that ocean was Tethys Sea. Tethys Sea. And what happened, he says, yesterday we have seen that it's kind of geosyncline, big geosyncline. What is geosyncline? Geosyncline is nothing but it is a big depression. Now this big depression is ocean depression. It can be ocean depression also. So Tethys Sea can be a geosyncline. So this geosyncline has a sediments at this bottom. And what he says, because of the squeezing of these these continents came together, there was a squeezing, and whatever the sediments were there in between them, they were squeezed, and these squeezed sediments uplifted, they rose, and then in between them, there is a mountain range. Mountain system or mountain range is formed. Okay, this was a simplistic explanation of Taylor that how mountains are formed. Okay, but now the next person, this is we will study in deeper that based on the Taylor's hypothesis, Taylor's drift hypothesis, one person who studied it deeply, and not just that, but he also gave much evidences to support his ideas. This person was Alfred Wegener. This person was Alfred Wegener. Now this Alfred Wegener was not a geographer. He was meteorologist. Means what? He used to study the climates. He was not a geographer. He was interested in the climates across the earth. Okay. Now what he do? He gave the theory called continental drift theory. Continental drift theory. Now what he says? Let us see. Or what he studied first of all. He was a meteorologist, so he was interested in studying Earth's past. Earth's past. How the Earth was evolved, how the plants, how the animals are evolved, okay, over the period of time. What happened to them when Ice Age was there? What happened to them when there was a warmer periods? We have studied these things, right, in the Earth's geological time scale. That when the Ice Age was there, the earliest Ice Age was. Tell me, anyone? The earliest ice age, 10,000 years ago, the name was Pleistocene Ice Age, right? So he wanted to study all these things and he was studying it, and then for his study, he found rocks. He again gathered fossil evidences. Okay, and through these evidences, he tried to build the climatic past of the earth. He want to build the chain, like what happened in this year, then this year, thousands of years ago. Like this, he wanted to connect the links. Okay, what would have happened in the earth's climatic past? Okay, now to study that, he gave some postulates. Postulates means some assumptions. For his studies, there were some assumptions. First assumption was he believed on Edward Swiss. Edward Swiss. What Edward Swiss said yesterday we see. Edward Swiss says that the earth is made up of three layers. The first layer is called Sial, the second layer is called Sima, third layer is called NIFE. Yes, the first layer is the outer layer, and then inner layer, and then innermost layer, that is NIFE, knife. Okay, so he said Sial is a lighter we know better. Sial is a lighter. Silica and aluminium, both are lighter materials. So Sial is a lighter. Edward Swift's idea is adopted directly by Wegener, and he said the Sial is moving over Sima. What he is saying now, Edward Swift never said this. Wegener is saying now that Sial is moving. The Sial is moving over Sima. Sima is the underneath part. Sial is moving over Sima. Because Sial is a lighter, it is moving over the Sima. Moving. They are moving. So if this is the Sial and this is underneath Sima, Sial is moving here and there over the Sima. Just imagine this. Okay. That means what? Sialic continents are floating like a wood block. Sial is like a wood block. This may be like a wood block. If you put the wood block over the water, it will float. Similarly, the Sial is floating over the Sima. Okay. Now, when this is happening, he said it is happening when there was a late Carboniferous time. Late Carboniferous time. Late Carboniferous time, you all know what happened in Carboniferous time? Tell me. If you have gone back and looked our last lecture, last lecture.
Fossils creates.
Yes. So at this time, what was happening? There he says there was a big continent. This big continent, he called it Pangaea. A big continent, a big supercontinent. He gave the name Pangaea. And around this big supercontinent, there was a big ocean, this super ocean. This super ocean, he called it Panthalassa. Okay. So today we have like 7 continents. Okay. But he said before that, in Carboniferous, late Carboniferous time, there was only one continent. This one continent was Pangaea, and it was very super massive continent. And around this there was an ocean, big ocean, and big ocean is called Panthalassa. Okay, but he says slowly, this Pangaea broke down. This Pangaea broke into 2 parts. He said this Pangaea broke into 2 parts, and these 2 parts are these 2 parts. Okay, the one part he says is Gondwana land. Below is Gondwana land, and one was Laurentia. One was Laurentia or Angara land. Angara land. Okay, so he says that late Carboniferous time there was a big continent called Pangaea, and around this there was a big ocean. Its name is Panthalassa. Now after some years, this some year is a mid-Mesozoic time. Mid-Mesozoic time. At this time what happened? He says the continent, big continent, broke into 2 pieces. One piece is called Laurentia, another piece is called Gondwana land. Now he is not telling you that why these 2 pieces are formed. He is not telling, and he also do not know. He just postulating, he just telling that this might have happened. And now when these 2 continents are formed, in between them there was an ocean, because there is a gap now, and this gap is filled by the water. Now this ocean he called, in between them it was a Tethys Sea. Similarly, on the lines of, who said this earlier? Taylor. So Taylor also said somewhat like that, right? But now Wegener is more organized. Wegener is telling these things in more organized way, because he said there was a Pangaea, Panthalassa, then it broke into 2. Okay. Now moving forward, what he says, after these 2 parts, still the breaking continued. The breaking continued, and what we got different fragments. And these parts started moving towards northwest direction. Okay. That means both Laurentia and Gondwana land again broke up into pieces. These continents broke up into pieces, and they started moving towards northwest direction. They are moving towards northwest direction. Okay. Why it is happening? It is happening because Sial is moving over Sima. They are moving now. He says they are moving. Why they are moving? They are moving because the Sialic component, the Sialic continent are lighter and they can float over the Sima. They can float over the Sima. Okay. Now he is giving you evidences also. He's not just explaining things. Okay. Now, what evidences or what is happening because of this movement? He says because of this movement, there are volcanisms, there are earthquakes, there is a mountain building process, there is an island formation. So, one by one, he is explaining everything. We will also look at those things, how it has happened. Okay. Now, he explained few features. Because of this phenomena, he explained few features. Let us see how. Okay. First, he said that the Sial is moving over Sima. Now, when this is happening, suppose this is a Sial and below it there is a Sima. When it is happening, when Sial is moving over Sima, there is a bound to have a friction. There is a bound to have friction in between them. Now, this friction lead to earthquake. This is the simplistic explanation he gave. Okay. Now, it will not just give you earthquake, but also volcanism. Because somewhere here maybe liquidous part, this liquidous part and then tearing, then there may be volcanism. Okay. He's not explaining deeply, but he's just saying that because of this movement, okay, there may be earthquake, there may be volcanism. Okay. Now the important thing he explained is the formation of fold mountain. Fold mountain. So what he said that whenever there is this suppose continent, okay, now this continent he said it is moving northwestward direction. Okay, this component or this continent is moving towards northwestward direction, and as it is started moving, what will happen? It is scraping the surface of earth. It is scraping म्हणजे काय? Suppose just give a crude example to you. दाढी करतात लोक. दाढी करताना दाढीचं खोरं जसं पुढे जाते तसं त्याच्या टोकाला काय होतो? फेस accumulate होतो. Similar to that, as this land is scraping, it will scrape the ocean sediments at its one edge. Let us see here. Okay. Now, this is the continent. Now, this continent is moving towards this direction, but it is moving over Sima. The Sial is moving over Sima, but Sima, he said, it is filled with the ocean deposits. Okay, at the bottom of ocean, there will be a ocean deposits. आता हे ocean deposits कुठनं बरं आले? तर there may be many fishes inside the water, oceans. The fish dies, their ooze get settled at the bottom. Okay, हे clear दिसते ना तुम्हाला? Or there is a lag?
Yes, sir.
Yes. So there is a ooze. Ooze means what? When animals die in the ocean, their body parts, they become very fine particles. So this is called ooze. We'll study later on in the oceanography that what are the sediments at the ocean bottom in detail. And these are the important questions for us. Okay. Later we'll see that in detail. Now there are some precipitates. Precipitates means in the ocean there are salts. Now these salts also gets deposited. Then there are cosmic dusts from the outside of environment. There are dust particles. They are coming and settling down. From the land, river is bringing lot of sediments. Now these sediments are also coming into the ocean. So all these ocean deposits are settled at the bottom of the ocean. Now this ocean bottom is having sediments. Now as this continent starts moving, this green color arrow shows that the continent is moving in this direction. It will do? It will scrape this material. This material will stick to this part. As it move forward again, it will again stick to this part. Okay, so this is the formation of mountain system. Okay, so this sediment will be stick to one face of this Oceanic continent. Okay, and this is nothing but the formation of fold mountain system. You understand? So at one edge of this continent, at one edge of this continent, pink color continent, all the ocean sediments are stuck. So this is kind of accretion. Accretion, okay, at the edge. So this diagram represents what? As the continent started moving. Let me give you another diagram. Okay, this is suppose Earth. Okay, and North America was here earlier. Okay, North America was here. North America was started moving to northwestward direction. So it turned to northwestward direction as it is moving. When it came here, what will happen? This part will get sediments at this and this edge. All the sediments are there now, and these sediments are nothing but Rockies Mountain. Rockies Mountain. You understand? Because he said that the continents are moving, and as they are moving, they will scrape the surface, they will scratch the surface of the ocean floor, and at the ocean floor there are deposits. These deposits will be patched or sticked, okay, accreted to the edge of the continent, and that's how we get the fold mountain. Okay, now similarly in the South America, suppose here was earlier the South American continent. Now it was moving here. Now when it came here, by this time what happened? This edge is also sticked with the continent oceanic deposits. So this is how he said that, and these mountains are formed, and these mountain, because these continents are moving in this direction, northwestward direction. So at this side only you will get deposits. But now when the question was asked to him that, there is another continent, this is Africa, suppose this is Europe, okay, and here is India, okay, everyone can see this, right? Here is India, and we have here Himalayan mountains, Himalayas. But now, can you differentiate that there is no land between them, like no water? That is, here is a Eurasia or Europe, and here is India, the Indian subcontinent, and between them there is a Himalayan mountains. He cannot tell how Himalayan mountains are formed because these mountains are in between the land. They are in between the landmass. So there is how it has formed. We do not have the answer for that. He can only tell you the mountain chain where there is an ocean at the other side. You understand? So he cannot say those fold mountains which are inside the interiors of the earth. Okay, inside the interiors of the continent. Okay. So similarly, he cannot explain this Ural mountain. Here are in Russia, there are Ural mountains. Ural mountains. So he cannot tell the origin of these Ural mountains also, but he can tell easily what is the way the Andes or Rockies. Even here in Africa, this range, Africa Chaya corner, because Africa was also moving like this. In Africa, this part there are mountains called as Atlas Mountain. ATLAS, Atlas Mountain. So they are formed because they are at the edge. They are at the edge of the continent. So he can easily say, they are because the continent moved. But he cannot explain the origin of Ural Mountain or Himalayas because they are inside this continent. Inside the continent. Okay. Now he further explains few things. He can explain you the small islands also. What he said, island formation. Island formation. He also explained the island formation. How he said when the continents were moving, this continent is suppose moving, this continent is moving, what happened? It got small fragments, it broken, and these broken trailing parts remained at the backward areas. or at the southern edge of this continent, and that's how these rock fragments are nothing but islands. What he said, when these big continents were moving in the northwestward direction, some broken rocks of this continent, some broken rock of this continent remain backward. Okay, they left back, and these left components are nothing but islands. So let us see where are these islands. For example, if you see the map, you will find this is like we have India here, right? And here we have Sri Lanka. Okay, even this is Africa. So nearby Africa, there is an island called Madagascar, right? So he said these small islands are nothing but the rock fragments from the bigger continent. These are the rock fragments from the bigger continent, and these now turned into the islands. But his explanation is not true, because these islands, if we studied properly, they do not collaborate, or these properties do not match sometimes with the original rock of this continent. Okay, for example, here are the, like, Japanese islands. Okay, so let us see, this is Kamchatka Peninsula, this is China, something like that, and here we have Japanese islands. Okay, these dots indicate Japanese islands. Okay, and this is Russia, China, here somewhere India and all. Okay, now these Japanese islands, he said these are also rock fragments, because this continent was moving in this direction, and that's why these rock fragments, like Philippines is also there. So these rock fragments remained at backward area or at back, and these, he said, are the continental origin. But we find later on that these rocks in the Japanese island are volcanic, and they are not the same as this continent's material. The rocks are different than the parent continent. Okay, so we will see this later. This you can write in your criticism of Wegener. Now, telling this story, it is very fascinating at that time for all to listen that continents etc. are formed in this way. It was surprising to everyone. Okay, and now to tell you the explanation how he just told this story and then gave the evidences. Now these evidences were awe-inspiring actually. Okay, now what are the evidences he gave? I told you earlier, he was the student of climatology. He studied the climates across the world. So he gave the evidences of rocks, he gave the evidences of fossils, as well as some earlier observations that some geographers observed. So his evidences are categorized into four main groups. The first was jigsaw fit. The first was jigsaw fit evidence. Second was structural evidence. Structural evidence of rock type. We'll see one by one these in detail. Rock type, composition. Third evidence that he gave was fossil evidence. And fourth evidence he gave was paleoclimatic evidence. Okay, first evidence he gave jigsaw fit, then he said structural evidence, that is rock type, then he also gave evidence of fossil, and then paleoclimatic evidence. Now let us see one by one that how he evolved this theory, okay, and proved that this should happen or this has been happening. Okay, so let us see first evidence of jigsaw fit. Now in jigsaw fit he said that the Atlantic Ocean, if you observe carefully, you will find that the Atlantic Oceans, both the coastlines are opposing to each other, but they can easily match with each other. So let us see if this is This is South America. Just draw smaller diagram. Okay, this is like South America. Okay, and this is Africa. This part of South America is called as a Cape of Saurok. Cape of Saurok or Sun God. Okay, and this part of Africa is called Gulf of, what is it? Gulf of, tell me. Guinea. K-I-N-E-A, Guinea. Okay, so Gulf of Guinea. So can you observe properly? If I put these two parts, part A and part B together, they can be easily fit with each other. This part, if I put inside of this, it will be easily fit. So if I draw this diagram, suppose like this, so here may be Africa, like this. Yes, so these two parts are easily fit into each other. That means somewhere earlier these two parts may be together, and later on they may broke into two pieces and then drifted apart, then moved apart. Yes, so this was his first evidence, okay, that the Brazilian part or Brazilian highlands are separated with the Gulf of Guinea. Brazilian islands were separated from the Gulf of Guinea. Okay, but this cannot be the conclusive evidence. Ki just baba shape sarkha distoy. Just shape is looking like this, and it can be fit inside of other part. Doesn't mean that continent are broken like this or this. But then he gave the second evidence. The second evidence is called rock structural fit. Rock or structural fit evidence. Okay, fit or match. Here he said, if you go deeper, these matching coastlines means this coast, okay, as I am drawing here, this much coast deeper, as you go down into the ocean, because in between them there is Atlantic Ocean, right? And here also, if you go inside, you will find that as you go deeper, as you go down, and you will find that their rock composition, layers of the rocks, they are also similar. How it is possible then? Okay, that suppose there is this layer of rock, similar layer of rock is also there in Africa. This is suppose your Brazilian coast, and this is Guinea coast. Okay, so upper layer of the rocks are also same from both the sides. Then as you go deep, then you find this type of rock, similar rock is also there on the African side. So as you go deeper from both the sides, you will find that the rock structure is also similar in the both the direction or both the sides. Okay, so that means it can be a conclusive evidence again. Okay, he was not stopped there. He also said some other things. So he said, so there are coal fields across the world. Coal fields across the world, and I think few days back we were discussing about it. These coal fields, like suppose this is North America, okay, and here is a Greenland, and here are European part, okay. So here is a Britain, okay. Here is Africa. So you will find one peculiarity that here are Appalachian mountains. In America, there are these mountain called Appalachian mountain. Appalachian mountain are full of coal. Okay, this coal is very good quality coal, because we have talked in geological time scale that these rocks are anthracite. These rocks are very good quality coal. Okay. Now, as you go to Greenland, then as you go up, you will find coal here also, coal here also. In this region, that is Nordic countries, these are called as a Nordic countries. These are Finland, Norway, Sweden. Okay. So in these countries, there are mountains called Jolen Mountain. K-J-O-N-N-E-N. Jolen Mountain. So in Jolen Mountains also you have coal, very good quality of coal. Okay. And one country which ruled us, that is Britain. You know better that why Britain become industrially so powerful, so strong. It is because of these penine coal fields. Penine coal fields. And that's how it started, that coal chain reaction. Okay, iron and coal, they were so abundant here in Britain that because of this coal they started producing machineries, and then these machineries started producing industrial goods. Okay, so industrial revolution started in Britain because of they were having this coal field, penine coal field, and this coal was a good quality coal. Can you see now that in this region only, this region is very close together. Okay, in this region you have very good quality coal. In this region you have very good quality coal, and this region is together. So he predicted that this today they seems to be scattered. Today they seems to be scattered, and in between these continents, that is European continent or American continent, you have an ocean. This ocean is Atlantic Ocean. Atlantic Ocean. But he said maybe these all islands were together. These two continents were together. There was no Atlantic Ocean earlier, and that's how these all coal fields. These are similar. The coal is also similar. Quality is also similar. So this all formed at one area only. So maybe North America here or Europe was here. Everything was here. These islands today seem scattered, but earlier they were at one place, and the coal field was developed at one place, and then they separated. Then these parts were separated, and today we see that these coal fields are scattered. You understand? So he is trying to tell you that the continents were earlier together. There was a big continent earlier, but it broke, and these broken pieces carried with themselves these evidences. Okay. Now, he further tells that the third evidence he gave was fossil evidence. Fossil evidence. Okay. Anyone, if they have any doubt, if they have any question, you can ask in between also. Okay. Now, this fossil evidence, what he suggests that when he studied, and he was climatologist, right? So he was interested in the climatic history of the earth. So he was studying animals, he was studying plants. Okay. And while he was studying, he found that the animals or plants found in this region is Brazil. Okay. This is South America, by the way, and this is Africa. Okay. Now you should understand, or whenever I draw the diagram, you should be able to understand, oh, which continent I am drawing. Okay. So if this region is matched with this coastline, this region, he found that the same type of animals or same type of plant species are present, or these fossils are present. So he found the fossils. He found the fossils of few ferns. This fern is example Glaciopteryx. Glaciopteryx, and Glaciopteryx is a fern. फर्न ज्याला आपण म्हणतो ना, हे असं पान, फर्नचं पान असतं, झाड. इट्स काइंड ऑफ प्लांट, बट इट्स नॉट फुल्ली प्लांट, इट्स फर्न. Then there are Cyanonathus. These are land reptiles. Land reptiles. Then he also gave the evidence of Lysosaurus. Lysosaurus. Then Mesosaurus. Mesosaurus. Now Mesosaurus was also reptile. Okay. Now he says that these are reptiles. They cannot cross over, right? They cannot cross this much water. They cannot go from here to here, this part to that part, just by swimming. And this, in between them, you had Atlantic Ocean, and it is big ocean, thousands of kilometers. Okay, this fern, obviously, this fern do not go there because fern is a fern. It's a plant. It cannot go. It do not have legs to go. This reptile, now this reptile can go, but this distance is very big. It cannot even travel this Atlantic Ocean. So he says that, oh, these animals developed at this region because these two parts were together. Earlier, these two parts were together. So the animals can roam from this area to that area, from South America to Africa earlier. But now they are separated, and now we find the evidences of their fossils scattered at the different locations. Okay, so this was his fossil evidence, and this was quite evident that yes, it can be possible. There was question also raised that this type of animal may have evolved here, like Glasiopteris may have evolved at Brazil, or and at the same time it may have evolved in Africa also. What is the wrong in it, right? Like we know that the humans evolved in Africa, then they traveled somewhere else, right? But if there may be a possibility that they may be evolved in Africa also, they may have born or evolved in India also. We don't know exactly. Okay, so questions were raised, but still the fossil evidence is one of the strong evidence that Wegener has postulated. Now there is a fourth evidence. The fourth evidence is much what we can say impeccable. This was paleoclimatic evidence. Paleoclimatic evidence. Now, to understand this paleoclimatic evidence, first you need to understand what is paleo. Paleo means old. Climatic, it's climatic. Old climatic evidence. Old means how much old? Millions of years ago, what would have happened? So, what are the observations he found? Just listen. Okay. For your information, there is one thing you need to understand, that whenever a plant grows in huge vigorous growth, if you want huge vigorous growth, what it needs full sunlight, it needs much rainfall, okay, it needs conducive climate, yes or no? So all these things are necessary, like hot and humid hot and humid. If the conditions are hot and humid, definitely the plant will grow vigorously, very fast. And this type of climate is only found in this tropical region. This region is called as a tropical region. This region is called tropics or tropical region. We know this, right? Because in tropical region, what happens? Sunlight is always perpendicular. Okay, so sunlight is much more in the tropical region, but as you go away from the tropics, the sunlight is slant, or as you go away from tropics, the sunlight is not much strong, and that's why here sunlight reaches very like small amount. That's why there is a very cold. That's why there is ice. Here is also very cold. That's why ice at the south pole, at the north pole also. Okay, so much of the heat of the sun is received in this area. Much of the heat of the sun is received in this area, and this area is a tropical area. Now you know better that the tropical areas, if they receive heat, most of the world's jungles are located in which area? Tell me. Here you have Amazon, then you have Congo forest. Yes. Yes, Rajita?
No, I was saying Amazon only.
Yes, Amazon, then Congo forest. Yes, so these are the great forest. Okay, these are big forest, very dense forest. These are called as a tropical evergreen forests. These are just located in this tropical area. Now, if there are forests, what will happen after millions of years? Suppose these forests gone underneath the surface. Then yesterday we have seen this Rift Valley system, and in the Rift Valley, what will happen? These plants go deeper, and after millions of years, in these Rift Valleys, what will happen? The formation of coal. Yes, in India also we have seen that in these Rift Valleys, the coal is formed. So if you want tons of coal, if you want much amount of coal, what you need? You need big jungles like Amazon, like Congo, right? But I told you just now that the coal, the best quality of coal in the world is found in which region? The best quality of coal is found in this region. The best quality of coal is found in North America, or it is found in this Jolene Mountain, or this is found in Britain. Now, are you confused or not? Because this region is very cold region. And in cold region, you don't find the dense forests. Dense forest, you don't find this type of forest. These forests are only in tropical region. This is suppose tropical region. But now the coal formed in the temperate region. We understood this temperate region, right? Earlier. Temperate region. So temperate region is a cold region. So how can this dense forest would be in this region, and then this dense forest turned into this coal? Wagner said, no, it's not like that. He said, America was earlier here. America was earlier here in tropical region, and at that time it had huge forests over the Americas, and these huge forests later on what happened? They converted into coal, and America drifted towards the temperate region. They drifted means the America moved upward. This moved northwestward. Even the Britain was earlier here in the tropical region. It moved towards here. Okay, that means the formation of these things were at different location. And now at the today's scenario or today's situation is that they are moved from that region, and now we find these evidences that here is a coal and all. Now when America was in tropical region, India was much below that. India was, now today India is in tropics. Today India is here. Yes, today India is here. This is our India. This is Sri Lanka. Okay, but earlier India was very close to this region. Now this region is Antarctica. India was closer to Antarctica earlier, but slowly, India also moved upward, okay, towards the tropics later on. And this today it's in tropics, but earlier it was in temperate region. Earlier India was in temperate region. Even Africa was also along with India. Africa was also with India in the temperate, very cold region. Okay, and the evidences that we find that in this region, here is the region called as Odisha. In Odisha, there is a called Talcher. In Talcher region, we have find the glacier striations. म्हणजे काय? The glacier या एरियामध्ये होता काही काळासाठी, and this glacier has, if it moved, it scratches the surface of earth. The glacier scratches the surface of earth as it moves, and because of that there are orkhade scratches, or these are called as a glacial striations. Okay, मग हे ग्लेशियल स्ट्रायशन्स आपल्याला आता दिसत आहेत. वी आर जस्ट फाइंडिंग दीज ग्लेशियल स्ट्रायशन्स हियर in the Odisha region. If we think, how can it possible that a tropical country, India today India is here, a tropical country can have a glacier? No, it's not possible. But yes, Wagner said that India was earlier here in the temperate region, and then it moved towards the tropical region. Similarly, in Africa also, in Africa, some part of Africa, we find this glacial till. Glacial till. So this till is nothing but glaciers deposits. Okay. So how in Africa? Africa is very hot continent, isn't it? So how in Africa there was a glacier? Yes, it was. It was in the temperate region earlier, and now it has moved towards the tropical region. It moved towards upward. Now it is hot, but earlier it was so cool because it was near to Antarctica, near to polar region. Okay, and that's why earlier it had these glaciers and then glacier deposits. So you understand? So these are the evidences, and this evidence, this was the paleoclimatic evidence. This was the impeccable evidence that Wegener gave, and this was the like uh, kind of enlightenment for many people, that why these features are there. These features are because continents move. Earlier this concept was not at all there, that the continent can move. A person is standing on some country, like I am standing over India, I am standing right now over Pune, and slowly मेरे पीछे की नीचे की फर्श मूव हो रही है. Nobody would imagine this. You understand? So this was an, we can say, a groundbreaking postulate or groundbreaking theory, which was led by this Wegener. Now there was a criticism. Always remember that whenever somebody tells you something different, people will not accept it easily, right? So similarly, questions were asked to this Wegener. Okay, so Wegener को question पूछा गया. The question was, now tell me why these continents are moving. And in one conference, actually, as a fun part, he didn't knew why these continents are moving, because he was not a core geographer. He was just a climatologist. So he said, give me a time. Tomorrow morning, I will tell you how these continents are moving. Okay. And then over the night, he thought, okay, I will tell them something. Okay. So he told few evidences that how these continents are moving. Because at that time, it was a time of 1912. It was a time of 1912. At that time, he did not knew that there was a layer called asthenosphere, a chewing gum like layer, as we have discussed. He did not knew at that time. This asthenosphere is discovered recently, okay, after World Wars. So we have discovered it recently. But earlier he didn't know there was some kind of asthenosphere which is semi-molten, and on this these continents can move easily. So he said, now these continents are moved because of two forces. So first force, he said, it was a centrifugal force. It was a centrifugal force. As Earth is rotating, these continents are like thrown away and they are moving. Okay, so this was his first explanation. It was because of the Earth's centrifugal force. The second evidence, he said, it is because of tidal pull. Tidal pull of sun and moon. Tidal pull of sun and moon. That means these continents are pulled towards the sun, towards the moon. These continents are pulled because of this gravitational force. Their gravitational pull is such that these continents are pulled towards the sun. So he said this. Okay. And then he said Kisial is moving over Sima because of these forces. But there was a person called Harold Jeffrey. Harold Jeffrey was very angry earlier because Harold Jeffrey's story nobody accepted, right? Harold Jeffrey said there is a like milk, there is a kind of cooling of that milk and then cream or that creamy layer, then that folds. Okay, so his theory was dumped. Now Harold Jeffrey was there to prove that these forces, that the centrifugal force or tidal pull, if it would be applicable, then the whole movement of the earth will stop. Earth will not able to rotate. Earth will not able to rotate if the sun will pull these continents towards itself, because that pull should be much more, so that the earth will stop rotating. It will not move from its position. Okay, and that's why the Wegener's theory was discarded for his lifetime. For his lifetime. And this was a sad part, that even if he was someone who gave this much grand theory, and which was true, but he could not explain that there are different forces which could move these continents from one part to other part. His theory, his flawed driving mechanism, his driving mechanism of these continents were not true, and because of this small mistake, his theory was discarded forever. Okay, but later on, the new theory emerged that we will see tomorrow in great details, that the Wegener's theory gave the bedrock, the base for the new theory called plate tectonics. Okay, But Wegener's ideas were relevant even today. Okay, so tomorrow we'll learn more about the plate tectonics. Till here, if anyone has any question, any doubt, you can ask. So this is wonderful, actually story, not story but theory, and this theory has much of the explanation of how earthquakes, how the your physical features, even forests, even coal fields. We'll see later on also in detail what are the crux of this theory, what things he explained furthermore when we compare it with the plate tectonics theory. Okay. Till here, anyone has any doubt?